So what's up? About 3 weeks ago, so I was contacted by this new energies company as you know I took it. I don't know whether you're going to call it like a contract or a freelance work from my own end. I was contacted to design a 200 barrel and 500 barrel storage tank for diesel and other fluids, which was very exciting for me because I've been for a long time now working hard on seeing myself as a full-time mechanical design engineer, and this was a very lovely opportunity because it allowed me, even if I hadn't done that in that way before. I have done 3D model, 2D drafting jobs, but as a mechanical engineer it takes more than just 3D modeling to assign that role to yourself, because you need to understand tolerance, you need to understand what you're designing, the standards that regulate what you're designing, and everything that has to go into you know how safe what you're doing is for people to use for the purpose it's made for. So that's it. It was very exciting, and it was very hard at the same time because I had to learn a lot by myself. you know Storage tanks, inlet, outlets, drainage, manhole, agitator, all of those things. So the first step I took was to chat GPT. So what are the specifications of a storage tank? What questions am I supposed to ask my client? And what do I require from him to design this? And basically, I learned that I know a lot of stuff too, but the inlet, what will you be needing? Will you need inlet? As in, sure, of course, you need inlet and outlet. As some certain things I had to ask him to include a type of support, saddle support or support bands. You know, um, Down the line, he told me he needed a ladder close to the manhole coming from the ground up, so you know, for access into the agitator. So I learned very fast what I needed to know. There's a calculation that I learned that from the volume of the tank, you're going to use that calculation to find out what are the dimensions and the size of the tank. So if someone approaches you now and said 500 BBL, 500 barrel, and so there's a calculation they're going to use the volume that it's supposed to take to try and get the dimensions of the tank overall. So I had to learn that. I didn't learn it as part it's in my head, but I wrote it down. I got down the calculations, make that I cross check with ChatGPT. And of course, I know ChatGPT is not always right, so I double checked because this is something that I have to make sure it fulfills the requirements that my clients require it to fulfill. You know, so you know that's it. By the time I knew the dimensions, the inlet nozzle, outlet nozzle, 150. I think I'm trying to give you specifications for the nozzle inlet. So that's about it. After leaving ChatGPT, I went on my drawing book to try and to draw and kind of visualize what I'm basically trying to do right there. So, and that's it. My workflow basically was to sketch dimension in my sketch, and write down the inlet nozzle, dimensions and the external diameter, the flange head of the inlet nozzle. It has a neck and has a flange head. The bolt sizes, number of bolts, all those things have to meet up with whatever the tank is required to do. So I'm really happy about that. as in like pages after pages. I just went around and made sure I did this right, you know, and it was really cool. It was a really cool process. Okay, so but a lot of head scratching stuff. So after I'm done sketching, dimensioning, knowing all my inlet nozzle and everything, that's when I got into the 3D modeling. Now, all design engineers use SolidWorks for 3D modeling of parts because it's better, it's better, it's easier to get as built drawings out of. I mean, AutoCAD can do what you need to do, but SolidWorks is more the industry standard. And speaking of standard, there are certain standards that I think is API that storage tanks need to meet up with. You need to have a corrosive tolerance. So a lot of things I might not have remembered to mention in this video, but take notes. If you're going on this journey, you have to learn a lot. You have to learn, and because this is something that you will not want to fail. You're a design engineer, and it has to meet up with all the requirements and use cases that your design, you know, should be. Okay, so it's basically the 500 BBL is divided into two compartments. That's um, the 500 barrel tank is divided into two compartments, and those two compartments has their separate inlet and outlet and drainage and agitators and manhole. So I had to position everything perfectly and with some sense of you know tech. Should I say technique? Because one thing, you need to position things at certain places so they don't disturb each other. You don't position your ladder in front of your agitator. It's obviously weird. Not weird. It just doesn't work. So that's just you need to understand where each thing should be relative to one another. So that's what I had to do. I had to write off the bat, point out where my inlet to be, where my outlet to be. So that's for that. I was speaking about the 3D modeling, and so most design engineers will use SolidWorks. Okay, I'm not yet a pro at SolidWorks is the way my resume says otherwise, but I'm actually a pro in AutoCAD 2D and 3D modeling. I'm a pro in AutoCAD, so I use what I'm good at for now. Meanwhile, on the low background, I'm working to be very good at SolidWorks. I don't play with my design softwares. I'm also working to be really good at my Aveva E3D. So I could actually get jobs for, you know, pipe modeling, simulation. Basically, there's this as a design engineer, there are two different paths you could take: a piping design engineer, or a mechanical design engineer. Personally, I love mechanical design engineering. I love design engineering as a whole. um Piping design engineer has to do with uh, you work with petroleum companies, and I don't vibe with working in petroleum companies, but I guess I enjoy working on, I have a lot of projects coming up now in my head, and meeting with a lot of professionals to bring it to life. So I just enjoy mechanical design engineering, you know but most importantly, design engineering as a whole. So that's it. I used AutoCAD to 3D model this. It was good. It was perfect. I used meters as my units. Um, meter as my units. I got everything I needed. And at the description, my deliverables were basically dimensioned third angle view drawings. I'm going to flash it in my screen. I'm going to show all of this later on. Dimensioned third angle view drawings with description and title and designer's name, Barango Emmanuel. And then I had a separate document that have a detailed description of everything that I was doing. Then that was basically it, you know. So I'm happy about how everything turned out. I'm going to keep working on my SolidWorks. I'm going to keep working on my Avatar E3D. However slow I am, I will keep going on. And I want you to like, subscribe. This is a new channel, by the way. So this is I'm going to show you videos of me 3D modeling. Enjoy.